All right, so today we're doing one-step inequalities, and we're going to be doing the classwork, all the even numbers. So number 2 is the first one we're going to do. I have negative 31 is greater than or equal to x minus 11. So what I want to do is I want to get the x by itself. I want to solve for x. So I need to get rid of this negative 11 somehow. What I'm going to do is I'm going to do the opposite. I'm going to add 11 to both sides. So when I do that, the negative 11 and the positive 11 are going to cancel each other out. So I'm only left with an x on the right side. I'm going to bring down the symbol that's in the middle. This one is greater than or equal to. On the left side, I have negative 31 plus 11, and that's going to give me a negative 20. So I get negative 20 is greater than or equal to x. Now, I can actually flip this over. I can put x on the left side, and I can put negative 20 on the right side. But the inequality symbol is still pointing towards the x. So I want to keep that symbol pointing towards the x as well on this side. So I get x is less than or equal to negative 20. When I write my solution set, I'm going to include braces and the variable x. This vertical line means such that, and then I can write my answer, x is less than or equal to negative 20. And then I close up those braces. This is called my solution set. So only numbers that are less than or equal to negative 20 belong in the solution set, and they have to be real numbers. Now let's do the number line. I'm going to draw a number line where we put the smaller numbers on the left side and the bigger numbers on the right side. But I'm going to put negative 20 in the middle. Numbers that are less than negative 20, like negative 21 or negative 22, are going to go here. And on the right side, numbers that are bigger than negative 20, like negative 19 and negative 18, are going to go over here. Since I have a less than or equal to, this equal to symbol tells me that I need a closed dot. So I'm going to put the closed dot on negative 20. And since it's pointed to the left, I'm going to shade to the left. And then I'm going to shade this left arrow. So I'm shading to the left because not only is this pointing to the left, but it's a less than symbol. And we need to consider only the numbers that are less than negative 20 or equal to negative 20. That's for the closed dot. Let's do number 4. I've got negative 17 plus p is greater than or equal to negative 13. So I want to get this variable p by itself, which means I need to get rid of the negative 17. Well, I can add 17 to both sides to get rid of that. So once I do that, the negative 7 and the plus 17 are going to cancel each other, and I'm only left with the variable p. I bring down the greater than or equal to symbol, just like it is. And then over here on this side, I have 17 plus negative 13. That's like 17 minus 13, and that's going to give you 4. So p has to be greater than or equal to 4. My solution set is going to be x, all real x, such that x, or actually it's p, so let me back up, all p, real numbers p, such that p is greater than or equal to 4. And that's my solution set. Now let's draw the number line. I'm going to put 4 in the middle. Numbers that are less than 4, like 3 and 2, are going to go on the left side. And numbers that are bigger than 4, like 5 and 6, are going to go on the right side. Since I have a greater than or equal to symbol, that's going to constitute a closed dot at 4. So I'm going to put that closed dot on 4. And then which way do I shade, to the left or to the right? Since it's greater than, I need to shade to the right so I can get bigger numbers like 5 and 6. Okay, speaking of 6, this is number 6. I have 16 is less than or equal to r minus 1. So like usual, I want to get r by itself, so I need to get rid of the negative 1 by adding 1 to both sides. So when I add 1 to both sides, I get 16 plus 1, which is 17. I bring down my less than or equal to symbol, and then the negative 1 and the positive 1 are going to cancel out on this side, leaving me with an r. So 17 is less than or equal to r. Now, if I wanted to flip that, I could put r on the left side, 17 on the right side, and then since the inequality symbol is pointing towards 17, I still have to point towards 17 to make it right. So r has to be greater than or equal to 17. So my solution set is going to be all the real numbers r such that that real number r is greater than or equal to 17. That's my solution set. Now let's draw the real line, the real number line. I'm going to put 17 in the middle. Bigger numbers like 18 and 19 are going to go on the right side. Numbers that are smaller, like 16 and 15, are going to go on the left side. Since I have this greater than or equal to symbol, I need a closed dot on the 17. Which way do I shade? To the left or to the right? Well, since this is pointing to the right, I need to shade to the right. That'll get all the numbers that are greater than or equal to 17, like 18, 19, and 20. All right, let's look at number 8. I've got r divided by 4 is less than or equal to negative 4. So for this one, I need to get the r by itself, but I need to get rid of this 4 in the denominator. Since I'm dividing by 4, I'm going to do the opposite of that, which is multiplying both sides by 4. So I'm going to multiply the left side by 4, and I'm also going to multiply the right side by a 4. So when I do that, the 4s are going to cancel out on the left side, leaving me with an r. I bring down my less than or equal to symbol, and negative 4 times positive 4 is negative 16. So now I've got my inequality solution, and I put it in my solution set. Now the number line has to include negative 16. I usually put that in the middle. Numbers that are less than negative 16, like negative 17, negative 18, they're going to go on the left side. Numbers that are bigger than negative 16, like negative 15 or negative 14, they're going to go on the right side. Since it's a less than or equal to, I'm going to use a closed dot on negative 16. Which way do I shade? The less than symbol tells me to shade to the left. So I'm going to shade to the left, picking up all the numbers that are less than or equal to negative 16, like negative 17 or negative 18. That's the way I need to shade. All right, let's look at 10. I've got b over 13 is less than 10. So for this one, since I'm dividing by 13 to start off with, I'm going to multiply by 13 on both sides. That's the only way I can get that 13 out of the denominator. So I multiply by 13 on the left side and the right side. They cancel out on the left side, leaving me with a b. a less than symbol, and then 10 times 13 on the right side is going to give me 130. So B has to be less than 130. I write my solution set. And then my number line is going to include 130 in the middle. On the right side, I'm going to have numbers that are bigger than 130, like 131 or 132. On the left side, I'm going to have numbers that are less than 130, like 129 or 128. Do I use an open dot or a closed dot? Since I have a less than symbol, no equal to on the bottom, I'm going to use a open dot or open circle on 130. Now, do I shade to the left or do I shade to the right? Since B has to be less than 130, I need to choose the numbers that are less than 130. So I'm going to shade to the left. Another way you can think about it is the less than symbol is kind of pointing to the left if you think about it as an arrow. All right, let's do number 12. I've got 234. It's less than 18 times m. So what I want to do is I want to get m by itself. So I need to divide by 18 on both sides. Once I do that, the 18s are going to cancel out on the right side, leaving me with just an m. I bring down my less than symbol. Over here on this side, I have 234 divided by 18. So what I'm going to do is I'm going to do some quick long division. Inside the long division house, it's going to be 234, my big number. I'm dividing by 18. So I ask myself, how many times can 18 go into 23? I'm only looking at the 23 right now. 18 can go into 23 once. 1 times 18 is 18. And now I subtract. 23 minus 18 is going to give me 5. And I bring down the 4. How many times can 18 go into 54? 3 times. Because 3 times 18 is going to give me that 54 that I want. And now I can subtract and have a remainder of 0. So this number is going to be a 13. 13 is less than m. I can also flip this around. Let's say m is on the left side and 13 is on the right side. I would have to point at the 13, so I need to point at the 13 right here. So the inequality sign is going to flip to being a greater than. So m has to be greater than 13. I can do my solution set. All real numbers m such that m is greater than 13. And now comes my number line. 13 is going to be in the middle. 12 and 11 are going to be on the left side since they're smaller. 14 and 15 are going to be on the right side because they're greater than 13. So I'm going to put an open circle on 13. This is because this symbol right here, the greater than symbol, has no equal to under it. So I'm going to use an open circle, which means I don't include 13 with my answer. But I am going to shade every single number that's greater than 13. So I need to shade to the right to get numbers like 14 and 15.